Hello everyone, welcome to our UGC Net Paper Wine course. I hope you're all doing well and excited to dive into the world of logical reasoning, which is our Unit 6. Today we'll be exploring the basics of logical reasoning. Our agenda for this session includes understanding the structure of arguments, different forms of arguments, the structure of categorical propositions, mood and figure. Let's get started. So the first thing we're going to talk about is, what is a statement or proposition? First of all, they both are the same. Think of statements and propositions in logical reasoning as simple yes or no questions. They're like light switches. They can only be either on, true, or off, false. There's no in between. For example, if I say, it's raining outside, this statement can only be true or false. If you look outside and it's raining, then the statement is true. If it's sunny, then it's false. Simple, right? Now let's talk about non-statements. In the world of logical reasoning, whether we call it a statement or a proposition, we're talking about the same thing. A sentence that makes a clear claim that you can check and say definitively if it's true or not. Think of non-statements as sentences that are like questions or commands. They can't really be true or false. They're just asking for information or telling someone to do something. For instance, if someone asks, "Where is the nearest coffee shop?" It's a question, an interrogative sentence, so it doesn't have a truth value. You can't say this question is true or false. It just seeks an answer. Similarly, if you tell your friend, "Please close the window," that's a command, an imperative sentence. Again, it's not about being true or false. It's about asking someone to do something. Both of these types of sentences, questions and commands, don't fit into the true-false framework that we use for statements or propositions in logical reasoning. They're just different kinds of sentences that serve different purposes in conversation. Understanding the structure of arguments. Let's discuss what makes up an argument. An argument consists of two essential components, premises and a conclusion. Premise. This is a declarative statement that provides foundational information or assertions upon which the argument is built. Conclusion. This is a derivative statement that logically follows from the integration of two or more premises, serving as the inference drawn from the initial assertions. Think of an argument as you deciding what to wear based on the weather. Here's how it goes. Premise is like your weather check. It's really cold outside today. Conclusion. This is your decision based on the premise. I should wear a heavy jacket. Here, your premise is a simple observation or statement about the weather. The conclusion is what you decide to do because of that statement. To put it even simpler, it's like when you're trying to figure out if you should go to a party. Premise 1. All my friends are going to the party. Premise 2. I enjoy hanging out with my friends. Conclusion. I should go to the party. This is how arguments work in logical reasoning. You take a couple of statements or premises, like facts or observations, and use them to come up with a conclusion. It's just like making a decision based on what you know. Now we will talk about the meaning of argument. Imagine you're figuring out if you should carry an umbrella today. Here's how you'd think about it using a logical argument, like a mini puzzle. Premises. These are like clues. 1. When it rains, everyone without an umbrella gets wet. 2. The weather forecast says it's going to rain today. Conclusion. What you decide based on the clues. You should carry an umbrella to avoid getting wet. Here's how it works. The first statement tells us what generally happens when it rains. People get wet if they don't have umbrellas. And the second statement gives us specific info about today's weather. Putting these clues together, the smart choice, conclusion, is to grab your umbrella on your way out. Just like in our rain example, any logical argument is built the same way. You start with some general or specific statements, premises, and use them to come to a conclusion. For instance, premises. All men are mortal. 2. Socrates is a man. Conclusion. Socrates is mortal. In this classic example, the first two statements give us the needed info, and from that, we conclude that Socrates, being a man, must be mortal. This whole process of using premises to reach a conclusion is what we call an argument. Each time you line up your facts, premises, and see what conclusion follows naturally. It's like following a recipe to see what you end up cooking. Forms of an argument. Deductive argument. A deductive argument is a form of reasoning in which the conclusion is necessitated by or reached from the premises. If the premises are true, the conclusion must be true. This type of reasoning is foundational in formal logic and mathematics. Example: Premise 1, all apples are bananas. Premise 2, all bananas are fruits. Conclusion, therefore, all apples are fruits. In this example, the logical structure guarantees the truth of the conclusion if the premises are true, demonstrating the characteristic certainty of deductive reasoning. Imagine you're putting together a simple puzzle with pieces that fit only in specific ways. If you have a piece shaped for a particular spot, it will fit perfectly, just like in deductive arguments. If the setup, premises, is right, the outcome, conclusion, is guaranteed. For instance, if every smartphone I've seen is a touchscreen, premise 1, and your phone is a smartphone, premise 2, then your phone must be a touchscreen, conclusion. It's like saying if all pieces in this section are blue and your piece is from this section, then your piece is definitely blue. Inductive argument. An inductive argument involves reasoning from specific observations to broader generalizations. While the premises of an inductive argument support the conclusion, they do not guarantee it. Inductive reasoning is common in science and everyday life, but involves a degree of uncertainty. Example: Premise 1, we have observed 1,000 monkeys, all of which were black. Conclusion: all monkeys are black. This example illustrates inductive reasoning. The conclusion is plausible based on the observations, but additional instances may prove it wrong, highlighting the inherent uncertainty of inductive conclusions. Inductive reasoning is like making a guess based on patterns you've noticed. Say you've seen your neighbor walking a poodle every day for a year. You might conclude, all my neighbor's pets are poodles. It's a solid guess, but not foolproof. Maybe they just got a cat. For another example, if every pizza place you visited serves pepperoni pizza, you might think, all pizza places serve pepperoni pizza. It's a reasonable assumption based on your experiences, but there might be a place out there that doesn't. Abductive argument, hypothetico-deductive argument. Abductive reasoning or abduction involves starting with an incomplete set of observations and proceeding to the likeliest possible explanation. It is often used in forming hypotheses and in diagnostic scenarios. This form of reasoning does not ensure the conclusion, but suggests a plausible link. Example: Premise: these plants conduct photosynthesis. Hypothesis: if the plants are green, then they would conduct photosynthesis. Conclusion: the plants are green. This example uses abduction to infer that the plants are green based on their ability to photosynthesize, which is a likely but not exclusively necessary characteristic. Abductive reasoning is like being a detective. You see some clues and come up with the most likely explanation. If you find wet floors, an open window, and it just rained, you might conclude it rained inside through the open window. It's not certain, but it's a sensible guess given the evidence. For example, if your car starts making a weird noise after you filled it with cheap gas, you might guess the cheap gas is causing the problem. It's not the only explanation, but it's a logical first guess based on what happened. Now we will have a brief discussion on assertion and reason. In logical reasoning, an assertion and reason question format comprises two distinct statements: an assertion, which is a declarative statement positing a fact, and a reason, which provides the rationale or explanation for the assertion. The task is to evaluate the connection between the two, determining whether the reason legitimately supports the assertion, and if both are individually true. Example: one must use sunscreen before going out. Reason R: because the sun emits harmful UV rays, and sunscreen protects us from them. This format requires the evaluator to assess not only the truth of each statement, but also the logical connection between them, ensuring the reason adequately justifies the assertion. Think of an assertion and reason like telling your friend why they should bring an umbrella. You should bring an umbrella today. Reason: because it's going to rain later. Here, you're not just throwing out random advice, you're giving a solid reason for your suggestion. The assertion is your main point, and the reason is your backup to prove that point makes sense. Let's try another everyday scenario. Assertion A: you should probably take a jacket when we go out tonight. Reason are, because the weather forecast says it's going to be chilly. In this casual way, you're saying, grab your jacket, that's the assertion, because it's expected to be cold, that's the reason. Just like in formal logic, you're checking two things. If it really is going to be cold, and if a jacket is indeed the right response to cold weather. Now it's the main event of the class. We are going to talk about the categorical proposition. A categorical proposition is a statement that makes a definitive assertion about the relationships between two categories or classes of objects. It is structured using four key components. The first component is subject term. This is the first class or category under consideration. Then we have predicate term. This is the second class or category, which is being related to the first. Next one is copula. This is a linking verb that connects the subject term with the predicate term. And at the end, we have quantifiers. These are terms like all, some, or no, which specify the extent to which the subject class is included in the predicate class. For example, in the proposition, all cats are mammals, cats is the subject term, mammals is the predicate term, are is the copula, and all is the quantifier. Think of a categorical proposition like labeling boxes in a warehouse. Let's understand this with an example. Imagine you're sorting boxes into categories. You have a big sticker that says fragile, and you slap it on every box that contains glass items. Here's how it breaks down. So here we have a subject term, boxes with glass items, and predicate term, fragile items. We have copula, are linking the boxes to the label, and the quantifier, all or every single one. You're essentially saying all boxes with glass items are fragile items. It's a straightforward way to make sure everyone knows these boxes need careful handling. Now can we discuss about properties of a categorical proposition? Each categorical proposition exhibits two properties, quantity and quality. So quantity, determined by the quantifier, it indicates the extent of inclusion of the subject class in the predicate class and can be universal, all, or particular, some. And quality, determined by whether the proposition affirms, affirmative, or denies, negative, the relationship between the subject and predicate classes. Let's understand with the example. So we have the proposition, all cats are mammals, where subject term is cats, predicate term is mammals, and copula is are. Quantifier would be all, and quantity must be universal, all cats. At the end, quality would be affirmative, which affirms the relationship. Let's say you're looking at your collection of books. You decide to make a statement, some of my books are novels. So the subject term is my books. Predicate term is novels. Copula is are, and quantifier is some. Here, you're not saying all your books are novels, just some. It's like picking a few books out of your whole collection and saying, these ones are novels. In quantity, you're either talking about all of something, like all boxes being fragile, or just some, like some books being novels. And in quality, you're either confirming something, affirmative, like saying yes, these are novels, or denying, negative, like saying no, these books are not textbooks. Now it's time to dive into the categorical propositions and their structures. Categorical propositions are assertions that connect two classes or categories through a specified relation. They are characterized based on two dimensions, quantity and quality. The structure of a categorical proposition combines these dimensions to form distinct types. The first one we have universal affirmative, which is represented as A, which is a proposition that affirms all members of the subject class are also members of the predicate class, structured as all S is P. For example, all cats are mammals. Then we have universal negative, which is represented as E, a proposition that denies any member of the subject class from being a member of the predicate class, structured as no S is P. For example, no cats are dogs. Then we have particular affirmative, which is represented as I, a proposition that affirms some members of the subject class are members of the predicate class, structured as some S are P. For example, some dogs are black. At the end, we have particular negative, which is represented as O, a proposition that denies some members of the subject class from being members of the predicate class, structured as some S is not P. For example, some dogs are not black. Now let's discuss about the types of quantities. Universal pertains to all members of the subject class. Particular pertains to some members of the subject class. Then we have types of qualities. affirmative or positive, which asserts a relationship or overlap between the classes. Then we have negative, which denies a relationship or overlap between the classes. To understand better, please look at the table. You can take a picture of it, or just pause the video and draw this on your notebook. Now let's discuss categorical syllogisms. Imagine a syllogism as a family dinner conversation that leads to a conclusion about who ate the last slice of pizza. It's basically an argument that uses 3 statements, 2 premises that lead us to one final conclusion. Let's break it down with pets and fur. Suppose we're talking about all mammals have fur. All dogs are mammals, so all dogs have fur. Here we're dealing with 3 main terms, forgetting about the fancy words like quantifiers and copulas for a minute. Major, minor, and middle terms. So the major term is the big conclusion term, so in our dog discussion it's creatures that have fur. And minor term is what we start talking about in the conclusion, like dogs in our furry friends chat. And middle term, this one bridges our premises but skips the conclusion party, like mammals in our example. Now, these terms have homes. The major term chills in the conclusion and the first statement, called the major premise. The minor term pops up in the conclusion and the second statement, yep, that's the minor premise. The rule is, always talk about the major premise first. Think of it like setting up a domino effect with your facts to knock down the conclusion. A little trick with letters. Consider this. All A are B. All B are C. So all A are C. Here, B is the go-between or the middle term because it's in both premises but not the conclusion. A is the minor term, kicks off the conclusion, and C is the major term, ends the conclusion. Let's learn the easy memory tricks. Major term, last word in the conclusion. Minor term, first word in the conclusion. Middle term, the buddy in both premises but fails before the conclusion. Examples to clear it up. No examples to clear it up. Minor term, blackboard. Major term, green. Some bread is butter. Minor term, bread. Major term, butter. Middle term, fun. It's the term that appears twice but never shows up in the grand conclusion. Like if we're debating whether bread can be like butter because they both get cozy with milk, milk is our middle term because it's hanging out in both premises but doesn't make it to the conclusion. So are you ready for the important topic? Yeah, it's the mood and figures. The mood of a categorical syllogism refers to the sequence of categorical propositions, expressed as A, E, I, or O, that represent the major premise, the minor premise, and the conclusion. The moods of a categorical syllogism are determined by the arrangement of the premises based on their quality and quantity. There are 16 possible combinations of these premises in terms of their quality and quantity. Because each of the 3 propositions in a syllogism can be one of these 4 types, there are 64, 4 types, for each proposition, possible combinations, or moods. These letters reflect both the quantity, universal or particular, and the quality, affirmative or negative, of the propositions. A, which is universal affirmative, all S are P. E, which is universal negative, no S are P. I, which is particular affirmative, some S are P. O, which is particular negative, some S are not P. In a syllogism, the mood is determined by examining the forms of the propositions used. For instance, major premise, some actors are singers, as we know it's particular affirmative, which is represented as I. Minor premise, all singers are dancers, which is universal affirmative, and is represented as A. And the conclusion, some actors are dancers, which is particular affirmative, and is represented as I. Thus, the mood of this syllogism is IAI. Let's elaborate this example. Imagine you're at a party and you notice something interesting. Your first observation, which is premise 1, some of your friends who are actors also like to sing. And the second observation, that is our premise 2, all of your friends who sing also love dancing. So the logical conclusion would be, some of your friends who are actors must also love dancing. Here's how we break it down. The first observation is about just some actors, not all, so it's a particular statement, and it's positive because it's saying something they do sing. That's what we call I in logic talk. The second observation covers all the singing friends and tells us they all dance, making it a universal and positive statement known as A. Finally, based on what we know from the first 2 points, we conclude that some of those actor friends must dance, sticking to the particular positive theme, another I. Now, before we move to the figures, you need to recall the structures of the propositions, which are subject term. This is the first class or category under consideration. Predicate term. This is the second class or category, which is being related to the first. Copula. This is a linking verb that connects the subject term with the predicate term. Quantifiers. These are terms like all, some, or no, which specify the extent to which the subject class is included in the predicate class. Let's have a look at the premise 1. Some actors are singers. Here subject term is actors. Predicate term is singers. Copula is are, and quantifier is some. Now let's have a look at the premise 2. All the singers are dancers. Here subject term is singers. Predicate term is dancers. Copula is are, and quantifier is all. Conclusion shows some actors are dancers. Subject term actors. Predicate term dancers. Copula are, quantifier some. So the mood, as we know, is IAI. Now let's talk about the figure. The figure of a syllogism depends on where the middle term, the term that appears in both premises but not in the conclusion, shows up. First figure, which is SP, the middle term serves as the predicate in the first premise and the subject in the second premise. This arrangement is considered very strong in classical logic because it typically allows a direct inference from the general to the specific. Second figure, which is PP, the middle term appears as the predicate in both premises. This figure examines the relationship between two subjects that share a common attribute, testing whether the connection through the attribute implies a broader link. Third figure, which is SS, the middle term is the subject in both premises. This figure is useful for exploring different attributes or subsets of the same group, helping to analyze how various characteristics within a group interact or contradict each other. Fourth figure, which is PS, the middle term is the predicate in the first premise and the subject in the second premise. This structure often links a specific subset of one group to a general characteristic of another group, exploring the implications of these connections. Let's understand them with the example. First figure, SP, subject and predicate. Premise 1 says, all men are good. Premise 2 says, X is a man. Middle term is men. Let's have a look at the explanation. In this figure, the middle term, men, serves as the predicate in the first premise and the subject in the second premise. This setup leads to a conclusion about X based on its association with men. The logic flows from a general statement about all men to a specific statement about X. If we talk about the second figure, PP, which is predicate and predicate, premise 1 says some workers are generous. Premise 2 says X is generous. So here middle term is generous. Let's have a look at the explanation. Here the middle term, generous, is the predicate in both premises. This figure often tests the link between two different subjects, workers and X, through a common attribute, generous. The challenge is to determine if the attribute shared by one subject necessarily applies to the other. In the third figure, SS, subject and subject, premise 1 says, all men are good. Premise 2 says, some men are dishonest. Here middle term is men. Let's have a look at the explanation. In the third figure, the middle term men appears as the subject in both premises. This structure typically examines different characteristics of the same group. It questions how one subset of a group, dishonest men, might relate to another characteristic of the group good. In fourth figure, PS, predicate and subject, premise 1 says, some workers are men. Premise 2 says, all men are good. Here middle term is men. Let's have a look at the explanation. The fourth figure uses the middle term as the predicate in the first premise and the subject in the second. This arrangement links a subset of one group, workers, who are men, to a broader characteristic applied to the middle term, men are good, leading to conclusions about the intersection of these groups. Now it is your turn to identify the mood and figure. Have a look at the question and answer it in the comment box. So that's all for today. Thank you for joining in. In our next class, we will dive into the classical square of opposition. Don't forget to subscribe, like the video, and leave a comment below. See you next time.